All, welcome to Tungal online classes. In this session, we will discuss last concept of alternating current. Concept is transformer. What is mean by transformer? How it works? And what is theory of transformer? In detail, we will see. Before that, we know mutual inductance concept. Wherever current changes in one coil, an EMF produces in neighboring coil. This phenomena was mutual inductance. Already we have seen this concept in electromagnetic induction chapter. On that basis, transformer works here. Let us see what is meant by transformer. See here, transformer is a device which converts low alternating voltage into high alternating voltage, or which converts high alternating voltage into low alternating voltage. That device we are calling transformer. In what way can define transformer? See here, the device which converts low alternating voltage into high alternating voltage and vice versa. I mean high alternating voltage into low alternating voltage. This we are calling transformer. Simply the device which converts low voltage into high voltage or high voltage into low voltage, that we are calling transformer. Then how it works? Let us take on what principle works here. Shall I take principle of transformer? Principle is, we know mutual inductance concept. Wherever current changes in one coil, an EMF produced in secondary coil. This phenomena is mutual inductance. Transformer works on the principle of mutual inductance. How it works? It works on principle of mutual inductance. See here. Then let us take what is construction. How to construction is there for transformer, in detail we will see now. See here. Next one is construction. See here. Transformer consists of a soft iron core. On soft iron core, two coils with more number of turns are wounding. This we are calling soft iron. See here, this is soft iron. On soft iron core, two coils with many number of turns, like this. Initially I will draw the diagram. This one, alternating voltage input, and look at me, this one I can see. So it is connected by load. See here, this I can call primary coil, this we can call secondary coil, and this we are calling load or output, simply load or output, and this we are calling input. Look at me, how the construction, and this we are calling soft iron. See here, very simple construction available. Transformer consists of a coil which is made up of solid iron On soft iron core, two coils with many number of turns are wound on separate limbs. Here two coils are there. This coil we are calling primary coil and this we are calling secondary coil. Which one we are calling primary, which one we are calling secondary, that is important. The coil with many number of turns connected to input source, I mean input alternating voltage, that we are calling primary coil. And the coil with many number of turns is connected to load or output, that we are calling secondary coil. And see here, the primary coil circuit with alternating voltage, this we are calling primary circuit, and the coil with many number of turns consist of output, that we are calling secondary circuit. Very simple. This we are calling input circuit, this we are calling output circuit. Very simple. How transformer work, how it converts low alternating voltage into high alternating voltage, or how it converts high alternating voltage into low alternating voltage, that we'll see. Directly we'll go. What is working of transformer? In detail we'll see. Working of transformer, how it works. See here, how it works, that we'll see. We know that whenever alternating input voltage is applied to primary coil, magnetic flux linked with the primary coil is increased. What I am saying? When input alternating voltage is applied, due to changing in current, magnetic flux linked with the primary coil changes. The changing in magnetic flux linked with the primary coil, that is affected to secondary coil. That is affected to secondary coil, so that in secondary coil EMF is induced. How it is? See here, once again I am saying, when input alternating voltage is applied to primary coil, magnetic flux linked with the primary coil changes. That changing in magnetic flux with the primary coil, that link to secondary coil, wherever magnetic flux link to secondary coil, and EMF induced in secondary coil. Very simple. We know that. Consider the primary coil contain this much number of turns, and the secondary coil contain this much number of turns. Wherever input voltage is applied, magnetic flux linked with the coil primary coil changes. So that what is EMF in the primary coil according to Faraday's second law? According to Faraday's second law, magnitude of EMF induced in the primary coil, how much it is? Magnitude is equal to rate of change of magnetic flux. What you are calling? A rate of change of magnetic flux. But the primary coil contain how much number of turns? This much number of turns. So that I can represent this is equal to NP into d phi by dt. NP into d phi divided by dt. This I can call equation number 1. Right? But wherever primary coil, in the primary coil current changes, magnetic flux produced around primary coil, that is linked to secondary coil. Due to changing in magnetic flux, that link to secondary coil, so that again in the secondary coil EMF induced. EMF is induced. How much EMF induced in the secondary coil? In the secondary coil ES EMF is induced. Then according to Faraday's second law, again where ES is equal to d phi by dt, then how many number of turns are available? NS number of turns are available in the secondary coil. Now I can take this is nothing but equation number 2. Right? We said that transformer converts low alternating voltage into high alternating voltage, or it converts high alternating voltage into low alternating voltage. How it convert, that we'll see. Look at me. In the primary coil, this much EMF induced. In the secondary coil, this much EMF induced. Very simple. Now divide equation 2 by equation 1. Shall I go here directly? I can take directly ES divided by EP. ES divided by EP. What is ES divided by EP? NS into how much? d phi divided by dt whole divided by NP into d phi divided by dt. d phi get cancel. Then what is remaining? ES divided by EP. ES divided by EP is equal to NS divided by NP. I mean, ratio of EMF in the secondary coil to primary coil is equal to number of turns in the secondary coil to number of turns in the primary coil. This ratio I can call a transformer ratio. This K. What is K here? This K we are calling transformer ratio. How it is? So here, this K we are calling transformer ratio. K we are calling transformer ratio. Look at me here. On the basis of transformer ratio, how it converts low alternating voltage into high alternating voltage. Actually, transformer can be classified into two categories. One we are calling step up transformer, second one we are calling step down transformer. Now I will explain what is meant by step up transformer, what is meant by step down transformer in detail. Before that, so let us take this ratio. This ratio we are calling transformer ratio, right? I mean ratio of EMF induced in secondary coil to ratio of EMF induced in primary coil. Remember this point. On this basis, let us take here. So shall I remove this? Just I will put only the construction of this one. Remember, just I want to remove this statement. Look at me. Look at me here. This is nothing but construction. See here. How to explain? How to explain? The transformer can classify into two category. I mean, one is step up transformer, second one is step down transformer. Before that, we obtain one equation, transformer ratio. What is transformer ratio? Transformer ratio is equal to K. K is equal to how much? K is equal to ES divided by EP is equal to how much? NS divided by NP. Right. Remember this. So I can make it. This is equation number 3 because already we are called equation 1 and equation 2. We said that transformer can classify into two categories. One we are calling step up transformer, second one we are calling step down transformer. See here. Two types of transformers are available. One we are calling step up transformer. Step up transformer. And second one we are calling step down transformer. Step down transformer. Step down transformer. See here. Step up transformer means the transformer which converts low alternating voltage into high alternating voltage. That we are calling step up transformer. For step up transformer, what is condition that we will see? See here. We know that transformer ratio. What is transformer ratio? Transformer ratio is equal to what? Ratio of EMF induced in secondary coil to ratio of EMF induced in primary coil. And one thing, the transformer is said to be ideal if input power is equal to output power. I mean there is no power losses, then such a transformer is said to be ideal transformer. For ideal transformer, how to say? For ideal transformer, how much input provide, that much output can be provided. I mean input power is equal to output power, or the efficiency of the transformer is 100%, then we are calling the transformer is said to be ideal. See here, for ideal transformer, just I want to put, for ideal transformer, no power loss. No power can be lost. Power loss means input power must be equal to output power. Input power must be equal to output power. I mean, if efficiency is 100%, efficiency means how to define efficiency? Efficiency is equal to output power divided by input power. Output divided by input. Simply this is input power. Output power divided by input power. See here, if the case efficiency is equal to one value, I mean 100%, then input power is equal to output power. For example here, if n is equal to 1, mean what value? 1 is equal to output by input. I mean if n is equal to 1, then input power is equal to output power. See here, input power, how to take? Input power is equal to current in the primary coil and voltage in the primary coil. See here, in the primary coil, how much current can flow? In the primary coil, this much current can flow, and this much amount of EMF can induce. Shall I take in the primary coil, this much EMF is induced, right? Is equal to input power. Input power mean what value? Here how much current can flow? Here this much current can flow. Sorry, this much current can flow in the secondary coil. See here, I can take secondary coil and EMF in the secondary coil is equal to ES. Later on this. Then from this what you got? From this you can get that EP divided by, from this you can take ES divided by EP is equal to how much? IP divided by IS. I call this is equation number 3. Then what about this? This is equation number 4. Now on this basis, now we will discuss what is mean by step up transformer and what is its condition. What is mean by step down transformer? What is condition of it? Look at me. Now look at me equation 3 and equation 4. See here. ES divided by EP is equal to NS divided by NP. But ES divided by EP is equal to IS divided by IP divided by IS. Look at me. Now just compare equation 3 and equation 4. What we got? Directly ES divided by EP is equal to NS by NP, but ES by EP is equal to IP by IS. By combining equation 3 and equation 4, what I can get directly? See here, shall I combine it? ES divided by EP is equal to, see here, what about that? NS divided by NP. NS divided by, but ES divided by EP is equal to how much? That is IP divided by how much? That is IS. Now I can call, what about this? Let us call this is nothing but equation number 5. Now what I said, step up transformer mean the transformer which converts low alternating voltage into high alternating voltage. I mean current in the voltage in the primary must be less and voltage in the secondary must be high, then we are calling step up transformer. See here, what you got this condition? Directly what you got? ES divided by EP. I mean, see here, if the case voltage in the secondary coil must be greater than voltage in primary coil, then such a transformer is said to be step up transformer. What are calling? Step up transformer. For step up transformer, what is condition? ES must be greater than EP. If ES must be greater than EP, then what is condition? What is condition? Condition must be NS must be greater than NP. NS must be greater than NP. Number of turns in the secondary must be very high. Number of turns in the primary must be low. Then such a transformer is said to be step up transformer. Again, if NS greater than NP, then what is condition here? What is condition? Condition IP must be greater than IS. I mean what? For step up transformer, I mean to convert a low alternating voltage into a high alternating voltage, what is condition here? What you got? ES must be greater than EP. NS must be greater than NP. IP must be greater than IS. What is IP? Current in the primary. What is IS? Current in the secondary coil. What is NS? Number of turns in the secondary. What is NP? Number of turns in the primary. ES represent voltage in the secondary coil. EP represent voltage in the primary coil. Remember this point. Then what is condition? To convert a low alternating voltage into a high alternating voltage, current in the primary must be more. Current in the primary must be more. Number of turns in the secondary must be very high. If number of turns in the secondary must be very high, such a transformer is said to be step up transformer. For step up transformer, shall I draw the diagram here? Look at me. I can take like this condition. Let us take this coil is there. This coil contain low number of turns of coil. So this is connected to what? This is connected to alternating voltage. So let us take this value is equal to how much? This value is equal to NP, primary number of turns. Then what about secondary? Secondary must be contain more number of turns of coil. So this is connected to output. This is connected to output. What about number of turns are available? NS number of turns are available. How much it is? EP. EMF in the primary. What is EMF in the secondary? That is ES. Here what current available? How much current available? Current is equal to what value? IP. And what about here current? Current must be equal to how much? That is IS. For step up transformer, what is condition? ES must be greater than EP and NS must be greater than NP. But current in the primary must be very high as compared to current in the secondary. I mean, Step up transformer mean the transformer which converts low alternating voltage into high alternating voltage by converting high current into low current. By converting high current into low current. Right? Such transformer we are calling step up transformer. Then let us go for step down transformer. See here. Shall I remove this step down transformer? Look at me this formula. Now let us discuss what is meant by step down transformer. Shall I add this formula once again? Look at me. How to take? What we got? ES divided by EP. ES divided by EP is equal to how much? NS divided by NP is equal to what value? IP divided by how much? IS must be equal to K, because ES by EP is equal to NS by NP is equal to K. I taken this is what value? Transformer ratio. In alternating way I can take if transformer ratio, if the case K is greater than 1, such a transformer we are calling step up transformer. Leave that. Now let us go for a step down transformer. What is condition for step down transformer? Before that, what was the definition of step down? The transformer which converts high alternating voltage into low alternating voltage. Which converts high alternating voltage into low alternating voltage. Such a transformer we are calling step down transformer. See here, step down mean EMF in the primary must be very high and EMF in the secondary must be very low. How much EMF is there in the secondary coil? ES EMF is available. Right or how it is? See here. If the case EMF in the primary must be greater than EMF in the secondary, such a transformer we are calling step down transformer. I mean which converts high alternating voltage into low alternating voltage. See here. If EP greater than ES, then what is condition? What is condition? NP must be greater than NS. NP must be greater than NS. If NP must be greater than NS, then what is condition? Condition must be IS must be greater than what value? IP. Just reverse of step down. Very simple. For step down transformer, what is condition? EMF in the primary must be very high and EMF in the secondary must be very low. Such a transformer we are calling step down. I mean convert high value into low value. To convert high value into low value, what is condition? Number of turns in the primary must be very high as compared to number of turns in the secondary. This we are calling structure of step up transformer. Then what is condition for step down transformer? How step down transformer can construct? In this way, look at me. Primary coil contain more number of turns. This is connected to alternating voltage. This what we are calling NP is nothing but number of turns in the primary. How much current can flow? IP current can flow. How much EMF induced? EP EMF induced. Then what is secondary coil? Secondary coil contain less number of turns of coil. It is connected to what value? Load. I mean output. Right. How many turns are there? NS number of turns. How much current available? IS current. How much EMF? ES EMF. For step down transformers, this way we are calling step down. I mean convert high voltage into low voltage. EP must be greater than ES. For EP must be greater than ES, what is condition? NP must be greater than NS. Number of turns in the primary must be very more as compared to number of turns in the secondary. And to convert high voltage into low voltage, what is condition? Current in the secondary coil must be greater than current in the primary. I mean, if it has high voltage, low current. High voltage, low current. It has low voltage, it must be high current. IS must be greater than IP. So, this what we are calling? This we are calling condition for a step down transformer. This we are calling step down transformer. Step down transformer. Very simple. For step up transformer, ES greater than EP, ES greater than EP, then K must be greater than 1. And for this, what is K value? K value must be less than 1. When K is less than 1, K less than 1, if EP greater than ES or NP greater than NS or IS greater than IP, then what is for step up transformer? For step up transformer, K must be greater than 1. When K is greater than 1, ES must be greater than EP, NS must be greater than EP. Then we are calling K is greater than 1. I mean, if the transformer ratio greater than 1, such a transformer we are calling step up transformer, and if K is less than 1, such a transformer we are calling step down transformer. Simply, so this is condition for step up transformer. What I can write? Step up transformer. Step up transformer. And what you are calling this? Step down transformer. But this is what? Working of transformer. Now let us see, when alternating voltage is applied to primary coil, some amount of energy losses in transformer. Then let us take what energy can losses in transformer. Next concept is, see here, shall I remove this? Next concept is energy losses in transformer. See here. Energy losses in transformer. Look at me. Before that, shall I take? I can take structure of transformer, how it looks like. So this coil contain more number of or less number of turns of coil. It is connected to alternating voltage. How many turns are there? NP number of turns. How much EMF induced? EP EMF induced. How much current can flow? IP current can flow. Right. Then what about this? This coil contain less or more number of turns connected to load. Load mean across it we are getting output. Right. How many number of turns? ES number of turns. How much current? IS current. How many number of turns? NS number of turns. When alternating voltage applied to primary coil, some amount of energy can losses. Energy losses are there. In transformer, energy losses due to heating. Second energy loss in transformer, energy loss due to flux leakage. Energy loss due to flux leakage. Then energy losses due to eddy current. Then again energy losses due to hysteresis. In transformer, energy can losses due to 4 reasons. Just I will explain one by one reason. First energy losses is energy losses due to heating. How the energy losses due to heating? Look at me. When alternating voltage is applied to primary coil, due to some resistance of the primary coil, some amount of heat is generated. That amount of heat generated can losses in the form of heat. So that energy can losses due to heating. To avoid heating energy, to avoid the loss of energy due to heating, this primary coil should be choice on the basis of the material has low resistance. If resistance must be very less, then we can avoid the loss of heating. Right. Second one, energy losses due to flux leakage. Wherever alternating voltage applied to primary coil, magnetic flux linked with the primary coil that affect the secondary coil. Whatever magnetic flux produced due to primary coil, all magnetic flux doesn't link to secondary coil. Some magnetic flux can leak in the air. So that here energy can losses due to flux leakage. Directly whatever magnetic field lines produced around primary coil, all magnetic field doesn't link to secondary coil. So that energy can losses due to flux leakage. To avoid the flux leakage, what to do? The primary coil and secondary coil all are overlap each other. I mean that tightly overlap each other, I mean primary coil overlap with secondary coil, then you can avoid the loss of flux leakage, right? Third reason, energy losses due to eddy current. Energy losses due to eddy current. Wherever alternating voltage applied to primary coil, circulating current produced. Circulating current produced. That circulating current we are calling eddy current. Due to eddy current, already we have known that lot of amount of heat can generated. Due to lot amount of heat up generated, their energy can losses in the form of eddies. To avoid eddy loss, what to do? To avoid the eddy loss, the primary coil and secondary coil are laminated on soft iron. They are laminated on a soft iron core. Due to that, eddy losses can be prevented. I mean primary coil and secondary coil laminated and the laminated wounding on a soft iron core. Next one, energy losses due to hysteresis. See here how the construction. Transformer consists of a soft iron core. On soft iron core, primary coil and secondary coil are wounding. Whenever alternating voltage applied, the soft iron core magnetized and demagnetized. We know hysteresis curve. During hysteresis curve, what happened? The ferromagnetic material undergo magnetization and demagnetization. When it go under magnetization and demagnetization, energy can loss. That loss we are what we are calling hysteresis loss. To avoid the hysteresis loss, what to do? To avoid the hysteresis loss, the material must be choice in such a way that the material must have low hysteresis loss. I mean the ferromagnetic actually it consists of a soft iron. When alternating voltage applied, the ferromagnetic material like soft iron, it get magnetized and demagnetized. During that, energy can losses. How the energy can avoid? This energy can avoid by making the material which has a low hysteresis. So this is concerned to construction, working and theory of transformer. So up to here the alternating chapter has been over. On this transformer, let us take only one simple example. Just I will solve a simple example. Look at me. How the example can be taken? See here. Simple, I will take an example on it given transformer. A transformer operates on 230 volt which has load current load current 2 ampere. Load current 2 ampere. Number of turns in the primary. The ratio of number of turns in the primary. Ratio of number of turns in primary to secondary is 1 divided by 25. 1 divided by 25. What is value of primary current? What is value of primary current? This is simple numerical on transformer. Question is very simple. Look at me. This is one transformer, right? The transformer operates on how much voltage? 230 voltage. Look at me here. 230 volt. I mean EP must be equal to what value? EP must be equal to 230 volt. Which has load current of 2 ampere. Load current mean output current. I mean current in secondary. How much current in secondary? Current in secondary is equal to 2 ampere. Again what he has given? Ratio of number of turns in primary to secondary. Primary to secondary mean what value? NP divided by NS is equal to 1 divided by 25. Number of turns in primary to secondary 1 by 25. What is value of primary current? What is value of primary current? I need this value. Very simple. See here. To understand this, let us go for ideal transformer. We know ideal transformer. If input power is equal to output power, such a transformer we are calling ideal transformer. Right? See here. Input power, how to write? Input power is equal to IP into how much? IP into EP. IP into EP is equal to what value? IS into ES. Input power is equal to output power. This we are calling ideal transformer, or else how to write? How to write? ES divided by EP. ES divided by EP. ES divided by EP is equal to how much? ES divided by EP is equal to IP divided by how much? IS. Let us call this is nothing but equation number 1. Right? Input power is equal to output power. But one more that, we know that EMF induced in secondary. One more equation. ES divided by EP is equal to what value? NS divided by NP. Are you following me? ES divided by EP is equal to NS divided by NP. This already we know. Then let us call this is equation number 2. Compare equation 1 and 2. What will get directly? See here. IP divided by IS is equal to NS divided by NP. NS divided by NP. But already we know this quantity. NP by NS is equal to 1 by 25. NS by NP how much? 25 only. Then what you got from this? See here. I need primary current. Primary current, how to write? This formula. This formula is equal to how much? This is how much? That is IS. NP by NS is 1 by 25. But here NS by NP. NS by NP how much? NS by NP is equal to 25 by 1. Look at me. What is current in primary? Current in primary is equal to 25. IS load current given. How much load current? Load current is equal to 2 ampere. Then what is current in the primary? Current in the primary must be equal to 50 ampere. I mean, current in the primary must be very more. Current in the primary must be very more. Current in the secondary must be very low. This transformer we are calling step down transformer. Step down means which converts high alternating voltage into low alternating voltage. Look at me. This is nothing but current in the primary coil. Up to here, the alternating chapter has been over. The numerical, NCERT numerical, we will discuss in the next session. Thank you, students.